So now children, today we are going to discuss a very important topic, and that is wavefront. A wavefront. Let me show you that a wavefront. Here you can see a wavefront. So our topic for today's discussion is about wavefronts. What is a wavefront? What is a wavefront, children? You know, in the previous lesson, lesson number 1 and lesson number 2, we have discussed about that a wave move, whether it is a longitudinal wave or it's a transverse wave. They propagate, they move, they carry energy from one point to another point. And we have seen the sound wave travel in the form of compressions and rarefactions, and transverse wave travel in the form of a crust and trough, and the longitudinal waves we have seen they travel in the form of a compression and rarefactions. So we know the wave travel, but now the topic is wavefronts. If you look at this picture, please look at this picture, children, and then I will try to explain you the meaning of wavefronts. When a stone, a pebble, is dropped in a still water, disturbance is generated, ripples formed, and they move from one point to another point without disturbing the medium. Now here in this picture, children, at any instant of time, at any instant of time, children, what happens? Disturbance travel in all directions. Children, the disturbance travel in all directions. The wave spread in a water, in a still water, and you can see here in the diagram that the disturbance travel. At the center point is the point where the stone is dropped, and then some ripples are formed, wave is generated, and that is spreading in different directions. But I want to mark here, actually I have to teach you about the wavefront. So at any instant of time, around the center point here where the stone is dropped, the first reason this portion is called the wavefront. And here on this wavefront, all the particles of water, means water molecules, at the same instant of time, they are at the same position. They are at the same position, they are at the same height, and that if you join all these points, you will get a wavefront. For example, another point, the second wavefront, all the particles here, after another interval of time, the second ripple here, all the particles, if you join, they are at the same position, they are at the same height, they are at the same in the same phase if you join. So you get another wavefront. So this is a wavefront, children. Instead of showing a wave that is propagating in the form of crust and trough, in this entire chapter, we are going to show the movement of a wave in terms of wavefront. In terms of wavefront, children. Again, one more thing here I want to tell you. If you want to see here, if I click here, a line joining all the points of a crest of a wave is called a wavefront, a definition. A line joining all the points of a crest of a wave is called a wavefront. If you have many wavefronts, join all of them and then you will get a wavefront. For example, suppose if I draw a wave, suppose a wave is moving, traveling in a river, water wave, like this, and my drawing is not perfect, but still, these are the waves are traveling in a river from left side to the right side, children, that the waves, the waves tsunami, the bigger amplitude, but the waves are moving from one point to another point. Now here I need to generate, I have to draw a wavefront. How would I draw a wavefront here? As per the definition, they said join all the crusts. So this is my first crust with the another one, and Another one, if I join all these points, all the points on the crest, the next crest is here, here, and here. If I join them, and the next one is here, the next one here, the next one here. So here I can see this, all these three lines, and this one, and this one, they are plane wavefront, plane wavefront of a wave. So this is the method, children, that how would I have drawn a wavefront. Wave is moving here, children. Remember that a very important point, a wave is moving from left to right side. So this is a wave moving. How the wavefronts are? You can see wavefronts are perpendicular to the propagation of the wave. Always, let me write here. Wavefront, I'm writing WF for wavefront. Wavefronts are always normal to what? Propagation of wave. Propagation of wave, or perpendicular to the direction of the movement of wave. So that is a wavefront, children. Another thing, always remember wavefront makes an angle 90-degree that is perpendicular to the direction of the propagation of wave. So basically, children, here the first category of the wavefront is a spherical wavefront. Spherical wavefront is obtained when the disturbance is created by a point source. Point source means, for example, in terms of light, if I have a bulb, and then bulb will emit the lights in all directions. So what kind of a wavefront is formed if I have a small point source which is creating a disturbance? And so here the wavefront will be all these circles. These are wavefronts. What are these red lines? The red lines are showing that the wave is moving in all direction. The wave is spreading. This is going in this direction, going in this direction, going in this direction, and all the direction here. And these red lines and circles, if you are good in mathematics, then you know the red lines and the circles, they are mutually perpendicular with each other. They are Wavefronts are always perpendicular to the propagation of wave. So we have a spherical wavefronts, and then the second one we have a plane wavefront. This example, you can see a wavefront is a parallel line. Another point in the wavefront, children, what this distance represent in wavefronts. What do you mean by this length? From the wavefront, children, you can also calculate wavelength. So this distance is called wavelength of a wave. Wavefront is always caused when a wave is there. If wave is there, then its wavelength will be there. So if you have a two consecutive wavefronts, and the distance between the two consecutive wavefront will give you the wavelength of that wave. It's not about now, children. In the previous diagram, we have seen by joining the crust, even you can form the wavefront by joining the trough also. If you join all the troughs of a wave, you will also get a wavefront. But again, the distance between two consecutive crust or two consecutive trough will give you a length that is called the wavelength of a wave. So remember, my dear children, please remember what this separation between any two wavefronts is called a wavelength, which is measured in meter. These things we have done already. Now let me move to the next topic. So this topic I have taken from your cognitive. Yeah. Now I want to discuss with all of you. If we have a wave, any kind of wave, whether it is a sound wave, whether it is a light wave, but this chapter is entirely based upon the water waves and the sound wave. Water wave and sound wave, children. And now the question is, if a wave is there, what happens if a wave strikes on a boundary? You know, children, just recall you have studied in your science classes in grade 6, 7th, and 8th about the reflection and refraction of light. Reflection means, you know, the bouncing back of light. Bouncing back of light in the same medium, that is called the reflection. What about the refraction? Refraction means that the bending of a light when light moves from one medium to another medium. And there is a new topic for all of you, grade 9, 10 students now, diffraction. Diffraction may be a new topic that you haven't studied this topic in your lower classes. Diffraction. Diffraction means that the spreading of light, or diffraction means that it is spreading, whether it is a light wave or sound wave. So we are going to discuss one by one about the reflection, refraction, and the third is the diffraction phenomenon. Now, children, one more thing about wavefront and reflection. Suppose if I have a boundary, this a barrier, this barrier. Look at that, the barrier is placed like a vertically along the y-axis, and we have an incident wavefront. Now, children, remember, wavefront means that the wave is going, you know, wave is moving, wave is propagating. But instead of showing a wave, like this, children, instead of showing it like this, we have what? A wavefront. So what kind of wavefront? It's a one line, even you can draw many lines, children. You may draw one more line, like this. So there may be many lines, but basically that we have wavefront. And the wavefront is how? Wavefront is parallel to the barrier. Wavefront is parallel to the barrier. So what happens if the plane wavefront strike the barrier? Suppose my hand is a barrier and this pen is coming, that the wave is moving in the form of a wavefront. When this wavefront strike here, what happens with the wavefront? What happens with the wave, children? When a wave strike on a mirror, on a hard surface, what happens? It bounces back. And the same thing has happened here. After bouncing, you can see that the blue line here, this is what the reflected wave means. Wave will reflect back, and the wavefront is there by the letter here, a blue color line. Even you can see that the red line represents that incident wave, and then another red line that shows the reflected ray, reflected, children. And the wavefront, actually the question is based on the wavefront. So this is a wavefront. It may be happen, suppose instead of that the light is coming from a distant source, or maybe the sound or the disturbance are coming from a very far away distance object. It may be possible that the disturbance energy or the wave is traveling or propagating from this point, children. Here is the source which is creating a disturbance, and then the disturbance are moving, means the wave strike here. Wavefronts should be perpendicular. That's why these green lines are here. Front always perpendicular to the wave. Wave is red line, and the planes wavefronts are green, and that are perpendicular. After reflection, when it strike here, what happens with the wave? It will bounce back, and then if it is bounced back, then you can draw the normal lines here. One more. One thing that you have to observe, children, in reflection, we are talking about reflection. After reflection, the wavefront is still parallel. They are still plane parallel. Parallel wavefronts are there, and they are perpendicular to the wave. And there is one more thing, very important thing. The wavelength after reflection is still same. There is no change in wavelength of the wave when reflection phenomena take place. Children, I want to show you, it is written here that please make a note in your notebook. During reflection, the wave speed, frequency, and wavelength doesn't change. No change take place in wave velocity, frequency of the particles means the number of oscillations, and third point, wave length of the wave remains unchanged. All these factors are constant. In reflection, whether disturbance is reflected when they strike parallel to the boundary or when they strike with some angle on the barrier, wavelength, speed, and frequency remains unchanged. So we have done with the reflection part, children. In reflection part, that the conclusion is speed, frequency, and velocity remains unchanged. Now we have refraction, that is the important, slightly more important compared with the reflection part. Refraction, the meaning is same when disturbance, energy, or wave are moving from one medium, enter into the another medium, it bends. It bends. But here the bending, children, just let me draw a diagram that in the lower classes, what you have studied about refraction, if we have studied, then just one example, suppose this is a glass slab, glass, and on it, if a light incident, and we need to draw a normal line. This is called angle of incidence, and when this is the air outside, so air means the less denser medium to into a heavy or higher denser medium, then the light bend and it bends towards the normal like this. It goes like this. So bending take place, reflection will take place. So here in this chapter that we are talking about, refraction will take place in the waters. Refraction will take place in a sound wave. So we have to show the refraction phenomena in terms of wavefront. Children, remember, in terms of wavefront, we have to draw refracted wavefront of a wave. That is the very important question in grade 9 and grade 10 in IGCSE exams. So let me show you. First, children, if you have a boundary like this and the wavefront on the left hand side of the boundary, and that is the right hand side of the boundary. Boundary basically means it's a interface which is separating one medium and another medium. So on the left hand side, I will assume that we have deep water, and the water waves are coming. Waves are coming from water. Disturbance are coming from the water, from the deep water. At the boundary, on the right side of the boundary, we have shallow water. Shallow. Shallow water means less deep water as compared to the left hand side. Now the question is, children, what happens with this plane wavefront? Listen carefully. What happens with this plane wavefront when it strikes with the boundary, when the boundary is again parallel to the plane wavefront? So in that case, you can see from the picture what you can observe. Again, remember, children, this is called wavelength. This is wavelength of the wave. This is an incident wavefront. You can see it is written here. When this wavefront strike with the boundary and the wave are moving from deep water to shallow water, or maybe the shallow water to the deep water, then what happens? You can see waves goes parallel. They pass. You can see they pass. They pass here. They pass the boundary, and then what happens here? You can see the length of the wavefront, that is the wavelength, it is decreased. Suppose this is, if it is lambda 1, now it is lambda 2. This is lambda 2. The space is decreased. So here I can write lambda 1 is greater than lambda 2. Basically, when refraction takes place, either the wavelength increase or decrease. The two things will happen. Either it will increase the refracted wavefront wavelength, either it will increase or decrease. Here we have example of that the refracted wavefront wavelength is reduced. Why it is reduced, children? Let me explain this point. The question is now, why it has been reduced, why the wavelength in the shallow water is reduced. To understand this, the meaning of this problem, children, that you have to recall this equation. Velocity is equal to frequency multiplied by wavelength. The one factor here, children, the frequency of the wave, frequency, whether it is in a deep water, means it means that whether the wave is in a deep water or the disturbance in the deep water or they are in the shallow water, the frequency of the wave always remains unchanged. Unchanged, children. Frequency of the wave. Frequency means basically that the whatever the oscillations are there, whatever the movement of the particle, that will be same. The wave is propagating backward and forward. The particle are oscillating upward and downward. That the number of waves generated per second, that the frequency is always same. That is constant. If f is constant, then I can write the equation v is direct proportional with wavelength. And if V is direct proportional with wavelength, then I know from my previous knowledge that when light or wave or sound wave entered from one medium to another medium, what happens? Velocity change. Velocity change. In deep water, children, if you don't know, remember, uh, let me write deep water. Speed of what molecules means the wave speed will be higher, velocity will be high as compared to as compare you please note it down, children, as compared to shallow water. In shallow water, the wave velocity will decrease. Wave velocity will decrease. If wave velocity decreases in the shallow water, then you can conclude the wavelength will also reduce, and that's why here we have less spacing between the refracted wavefront. Now I want to move to the second diagram here, children. Now in the second diagram, the boundary is little bit inclined. Okay, so the boundary is a different method. It is placed in a different position. Again, in the left hand side, we have a deep water. On the right hand side, we have a less deep water. If I say, as per this diagram, children, if I ask you one question, okay, what kind of medium is there in the left hand side and what kind of a medium is there in the right hand side? How will you find out the what kind of a medium will be to the left side and to the right side? Then how will you give the answer of this problem? Then you can say in the right hand side the refraction takes place and the wavefront width has been decreased. Wavelength of the wave is reduced. It means in the right hand side the wave velocity is decreased. That's why the wavelength is decreased. And if the velocity in the right hand side is decreased, so it means I in the right hand side I have a shallow water, and in the left hand side I have a deep water. Now children, the question is in the next 10 minutes I want to explain how to draw. Actually in the exams, let me draw this diagram one more time by myself. In exam, what kind of questions come? This is a boundary, and children listen carefully. This is the wavefront. Okay, many lines you can show. So this is the wavefront. What happens with the wavefront when the light or the disturbance or the energy or the sound or the water waves they pass this boundary? You need to draw the wavefronts. You have to draw complete wavefront. How would you know that? As per this diagram, how would you know that the wavefront will be like this? Why it is not like this? Why it is not like this? Why this is like parallel lines? So here, children, we are going to understand how to draw a wavefront after reflection. Children, I want to show you one more thing. And this question, look at this question. This is from the IGCSE past year papers. That is the problem. Figure 5.1 shows 6 wavefronts. You can count these 6. Suppose first, second, third, fourth, fifth. 6 wavefronts are there. Traveling on the surface of a deep water, the wave is incident on a boundary with the region where the water is shallow. So on the right hand side, the shallow water is there. And then children, you need to complete this diagram. What happens? Now let me first draw. My question is, what about the nature of the wavefront? Whether these will be like these lines will be there, or some kind of this kind of line will be there. So that is the problem, that we have to identify what happens with the wavefront here, children. How would you complete this diagram? This is an IGCSE question, children. Next year you have to face, even your term and exams, you have to face this kind of question. But how would you find the answer? Now, children, please listen carefully. I'm giving a method, one method. First method that you remember, RNAR. This word, a random word, RNAR. Whenever there is a diagram is given, whenever a wavefront is given in exam, children, first this R will call, first complete, draw a ray striking on the boundary. And here, I have just extended this line. Whether this line is there, whether this ray is shown in the diagram or not, first you have to draw. First step is, children, draw a ray incident on the boundary. Anywhere, children, you need to draw a wave. Then after that, the second is this N here. That N is for normal. Normal means here you need to draw a normal line. Where? At the point where the first ray incident on the interface. So let me draw the normal. This is a normal line. Okay. So this normal means this normal is normal to the boundary, children. It should be on the boundary. For example, uh, this is our boundary. What will be the normal? This is the normal. If the boundary is like this, normal is like this. Normal is normal. Normal means perpendicular actually, 90-degree angle. So I have created this angle normal here at the boundary. Suppose this point is the point P. The third point A here actually, and I can mark here this angle is angle of incidence. I have marked this A for angle of incidence. Whatever this angle, whether it is 10-degree, 15-degree, 30-degree, whatever this angle of incident ray with the normal. Third point, children. This side we have deep water. This side we have shallow water. I know that here the disturbance or the wave will refract. How would it will refract, children? Deep water means the speed of the disturbance will be higher, wave velocity will be higher. In the right hand side, it will slow down. If it slow down, so instead of going straight, children, so instead of going straight, this wave will not go in this direction, but it will bend. Let me draw. This will bend like this, and it will go here. So this ray I have drawn. This is the refracted ray. So first, children, you have to draw refracted ray. You have to draw refracted ray. Then on the refracted ray, you have to draw the normal lines. So if I show this refracted ray here on another side, here children, this is a refracted ray. I need to draw normal because this is a ray and the wavefronts. I have to show the wavefronts, and wavefronts I know they are perpendicular to the wavefront. So if they are perpendicular to the wave, so the normal will be like this. That's the normal. So these are the normal, children. So you need to draw this normal line, but I will do it in a more systematic way, that the first wavefront here in the deep water, and when it entered into the less deep water, it will bend, wavefront will bend, and I can, let me scale here, the straight line I can do something like this. The second one here, something like that. Third one like this, and similarly the fourth one like this. And so this kind of wavefront will be there. This kind of wavefront, children. So this wavefront, which one? This one, this one, all these are normal to the ray. Even still, this diagram is not a perfect diagram. You can use a scale ruler to draw this diagram. But if somehow, children, if you draw, again, let me just do a rough calculation. This is the reflected ray. If you mark the wavefront something like this, that will be the wrong representation of this wavefront in this case. Something that will be wrong. So I have given you a method, RNAR. Again, what is this RNAR? First show the ray, normal, angle of incidence, and that is the reflected ray. On the reflected ray, just draw normal lines. Drop 2, 3, 4 lines. Reflected ray. Now, children, I want to stop this meeting here, and that I want to give you some time for discussion.